Hello, and welcome to the dot product of vectors lesson for Edgenuity Learning at Home Precalculus. Hopefully you've watched the instruction lesson because I will be referring to a lot of the formulas there. Obviously that's where you should first learn, and this is the practice. This is just to make sure if you get stuck on one of the steps on a practice question that you know what you're doing. So let's go ahead and get started. So the practice question number one says a constant force as a vector 2333 moves an object along a vector 2018 where the units are in pound of feet. Find the work done. Hopefully either from physics or the instruction video, we know that work equals force times distance. If we are given those as vectors, we just need to find the dot product of those vectors. So this first one should be pretty easy for us. All we need to do is find the dot product of these vectors. So 2333 and D is 2018. So 460 33 times 18. Let's plug that in our calculator real quick. And when we add those together, we should get 1054. So our unit should be foot-pounds, and sure enough, we do have 1054 foot-pounds. Okay, question number two. Find the dot product of A, B. It gives us, looks like all we need to do is do the same dot product that we did before. Okay, so that's pretty straightforward as they get. For question number three, now these next two questions do take a decent amount of work. It says write the vector u as a sum of two orthogonal vectors, one of which is a vector projection. So the first part of this question is asking us to write u, which we can see is negative 6, 8. I've drawn that one right here. We have u. It wants us to write it as the sum of two orthogonal vectors, or two 90-degree vectors being added up. And I broke that down using the green arrows on there. Here are two orthogonal vectors we could use. This one right here and this one. And this one at the bottom down here is the projection of u onto v. Remember, projection, you can think of it as like the shadow from some sunlight perpendicular to a vector. So the green lines here should be perpendicular to vector v. And if they were coming down on vector u creates this shadow down here at the bottom. That is the projection. And the other vector we're going to use, the orthogonal vector, needs to be 90 degrees right there. So we're going to call these other two vectors, I'm going to call this one u2. And this one right here is going to be u1. So when I add up u2 plus u1, I know that it ends up equaling right here. Right, let me do it in a slightly different color here. I get u2 plus u1. We get vector u as a sum of vectors u2 and u1. And it's a 90-degree angle right there, so that's the sum of orthogonal vectors. Right. So the first thing we need to do is find this projection. And then we can actually find u1 by taking u and subtracting u2 to find the other vector. So let's first do that. Luckily, it gives us instructions on how to find a vector. We can use this formula, a projection of a vector, by using this formula. So very first thing we're going to do is find the projection. So dot product of u and v over the magnitude of v squared. So there's the magnitude, and then squared, the radical and the square should end up just canceling out whenever we're doing that one. And then the last thing we will do times v as well. Right, so the first thing we can do here is the dot product in the top. Negative 6 times 7 is negative 42. 8 times 1 is 8. And the denominator 7 squared is 49. And 1 square root squared is just 50. So 49 plus 1 is 50. And we end up getting negative 42 plus 8 is negative 34 over 50. Times 7 and 1. All right, so from here, we should be able to take this question and just multiply this in, kind of like distributing into each of these. Negative 34/50ths times 7. Let me plug that in the calculator real quick and see what we get. Negative 34 divided by 50, negative 4.76. And obviously the other one, negative 34/50ths equals negative 0.68. So technically we do have our answer right here. What we actually just solved for was just the projection, but because we want to write u as a sum of orthogonal vectors, one of which is the projection, we know that the projection is one of the two vectors that we're using, so it looks like it's going to be answer choice D. Now what we could do from here, now that we have that, is we could actually solve for u1 as well, just to make sure, and we are going to go ahead and do that. So I know that u is the same as u2 plus u1, and if I wanted to solve for u1, I could just subtract u2 from both sides. And so if I know that u is negative 6, 8, and u2 that I just came up with is negative 4.76. Let me rewrite all of that. So negative 6 minus negative 4 gives me a negative 1.24. And then for the other part, 8 minus negative 0.68 should give me a 8.68, because minus and negative, same thing as plus and positive, so 8.68. So we know that u1 is going to equal that, and that is the other one that we get up there. All right. Same thing on this one. It asks us to find, write the vector u as a sum of orthogonal vectors, one of which is a projection. So same thing, you can see in red here, I drew vector u at negative 9 and then 3. Negative 9, negative 3 is vector v, and if I'm projecting u onto v, we have our blue perpendicular projection, that shows we're going to end up with this projection right here. And that's going to be one of our two orthogonal vectors. So this piece right here I can call U2. And this piece over here is our other vector I can call U1. So U2 plus U1 gives me to the same point as vector U on there. Okay, so we literally use the same formula. We should be able to do this. And once again, once we get the first step based on our answer choices, we should be able to know the answer without having to even solve for U1. We're going to know what the correct vector is from U2 that we have to add together, U2 plus U1 to equal those. So let's do it again. U is negative 9, 3. Over the magnitude of v squared, so square root of negative 9 squared plus negative 3 squared, and then this whole thing is going to get multiplied by negative 9, negative 3. All right, so first let's do the dot product. Negative 9 times negative 9 is 81, plus 3 times negative 3 is negative 9. Here the square and the square root cancel out, and we get 81 and 27. No, 81 and 9, so 90. 81 plus 9 is 90, yep. So I end up getting from all of this here, I get 72 over 90, or I guess divided by 9, that's 8/10. So 4/5 or 0.8, doesn't matter, times negative 9, negative 3. Okay, so multiply those 8 times, we get negative 7.2. And what do we get? 2.4, looks like, yeah. So negative 2.4. So that is our projection. That should be this blue piece over here that we had, the projection, and that is one of the two orthogonal 90-degree vectors we could add together. So there's one, the other one, this one is answer choice A. That is one of the two orthogonal vectors. And if you wanted to make sure, you could do U equals U1 plus U2 and solve for U1. And you would end up getting this value here for U1 as well. All right, question number 5. I already have some work done here, but let's start over and make sure we know what we're doing on this one. It says find the angle between some vectors. This is real easy if you just use the dot product and the magnitude little formula they gave you in the notes. So really all we need to do is find the dot product and the magnitude and then do the cosine inverse in our calculator. So we're going to do cosine theta equals U is 8, negative 3, dot negative 3, negative 8, over the magnitude of U times magnitude of V. All right, so the dot product that we can do right here, 8 times negative 3 is negative 24, plus positive 24 equals 0 over, who cares what happens here, because what's 0 over any number? 0. So we're going to be doing the cosine inverse, or cosine of theta equals 0, or angle equals cosine inverse of 0. So this is saying, what is the angle measure when the cosine of that angle is equal to 0? And if you think about the unit circle, when is the, negative 1, positive 1, 0, at what angle measure is x 0? And we know at 90 degrees, so this angle should equal 90 degrees. So that's a pretty easy one there. As soon as we get 0, we don't even have to do any of the work down at the bottom here. We don't have to find the magnitudes because we know it's going to eventually end up being 0 over some number. All right, for question 6, same thing. We have these written in terms of I and J. In reality, you don't even need to worry about the I and J. As you can see from the notes that I already had on the side over there, this is 1I plus square root of 7J. I can just write it as 1 and square root of 7. And same thing with V, I can write it as negative 1 and positive 9. So then I need to do cosine, of theta equals 1 square root of 7, dot product on the top. So V is negative 1, 9, and magnitudes on the bottom. 1 squared plus square root of 7 squared, negative 1 squared plus 9 squared. So for the dot products in the numerator, 1 times negative 1 is negative 1, and plus square root of 7 times 9 is 9 root 7. In the denominator, the magnitude, 1 squared is 1, square root of 7 squared is just 7, so 1 plus 7 equals 8, so square root of 8. And here I get a 1 and an 81, so square root of 82. So then I just need to plug in my calculator. You might want to use Desmos calculator where you can type this all in at the same time, because if you have to go piece by piece from some phone calculators, it does get a little bit harder. When you're done, did I do this one already? I think I did. I'll type it in again. Looks like we get approximately 27 degrees on this one, so it should be 27. Here's 1/10 of a degree, so 0.0. Yeah, that should be correct. Okay. Obviously on this one, we did need to do the whole bottom step as well. We didn't equal 0 up here, so we did need to find the magnitudes on the bottom. Make sure you're using degrees on your calculator as well, because if it's in radian mode, you're not going to get these, especially when you're doing the inverse sines and cosines. All right, number 7, use the dot product to find the magnitude of V. I don't know why it says do dot product. Just, you got an X, Y, you got an X, you got a Y. Find this. You're gonna get I know that you guys know how to do Pythagorean theorem. It just says find the magnitude, and that just means what's this number going to be here from the vector that has an x value of 7 and a y value of 24. So just do a Pythagorean theorem. That's kind of ugly, I know, but you guys know how to do Pythagorean theorem. 7 squared plus 24 squared equals 25 squared. Same thing. That was easy. Yep. I don't know why you would use dot product to find these magnitudes when we learned Pythagorean theorem in middle school is what I would do. I honestly don't even actually know what you're doing with that. I didn't look at the notes for this video. All right, so for this one, find the angle between these two vectors to the nearest degree. Okay. Although it may look different from some of these other questions, where do they go? Yeah, it's the same as these. Hey, look, you got a vector, find the angle between them. Great, we're going to do the same thing for this one. You have a vector, find the angle between them. That's exactly what we're going to do. So U, I guess, is this one, 7, -4. And V is 1, 5. So that should make it real easy to go ahead and plug those into that same formula we used earlier to find the angle measures. So cosine of theta equals 7, 4, dot product 1, 5 over magnitude of U times magnitude of V. And that's the magnitude, remember, is just the hypotenuse on a right triangle or a Pythagorean theorem question is how I solve them. So first let's do this dot product in the top. 7 -20 over, whoops, what do we get here? 65 Oops, I don't know why I did that. I don't know what's happening here. So square root of 26. All right, so then we just need to do the cosine inverse on both sides to be able to get rid of the cosine himself, or just the angle. So the angle equals cosine inverse of all of that. And plug it in our calculator. 1 nearest degree. Now they did to the nearest tenth of a degree, but I think it's about 108. So 108.4 is the closest one on there. Is that right? Yes, that is correct. Yeah. All right. Oh, we're on the last one. That's convenient. Number 10. Find the work done by a force of 21 pounds acting in the direction 2, 5. Moving object moving from 0, 0 to 7, 0. So conveniently, this part here is going to be real easy for us. This one, we need to figure out a force vector. So it tells us the magnitude of the force is 21 pounds, and it tells us the direction, but we don't have an actual vector representing the force. So if it's moving in the direction 2, 5, so 2, 5, uh, the force vector is moving this direction, right? And there's 21 pounds of force. Um, Ultimately, we're putting a force, it looks like it's going up and to the right some, but we're actually moving some object to the right from 0, 0 to 7, 0. So although we're lifting it up and pushing it forward, we want to know how much work as a quantity is done. We need a vector to represent this. And then we can just, we know from, I think it was the very first question, that work equals force times distance. And we can do that as dot products as well. So we'll start with the easy one. If you go from 0, 0 to 7, 0, that vector is going to be 7, 0. That part's easy. But we need a vector to represent the force here as well. So we basically need an x value and a y value right here. So if you can't just use 2, 5, because obviously this is not the values of a right triangle, 2, 5, 21. What we can do though is a couple of different things. You can go back and follow the last question on the instructions on how to find the component parts of this 21-pound force, how much it's going in the x direction and how far it's going in the y direction. Or an easier way to do this one is actually to do a little bit of trigonometry, find this angle using the direction vector. And then once you know this angle, just do 21 times cosine of that angle to get your x component, and 21 pounds times sine of the angle to get your y component. So I know that tangent of an angle equals opposite over adjacent, or tangent of an angle equals 5 over 2. And if I do tan inverse of 5 halves, and we should get our angle equals approximately 68.1986. So our angle right here equals 68.1986 degrees. From there, if I want to find the components for the x direction and the y direction, you can just do 21 cosine of that angle. And our y direction is going to be 21 sine of that angle. Okay, so let's see what we get for those, and let's go ahead and write those down. So for our x value, 21 times cosine of 68 degrees equals approximately 7.8. And for our y component, we do the same thing with the 21 sine of 68.1986. And looks like we get 19.5 is what I'm going to use on there. Oh, that looks weird. All right, so now that I have my force written as a vector, I should be able to just multiply using the dot product. And so let's go ahead and do that. I get 7.8 times 7 plus 19.5 times 0. Whatever 7.8 times 7 is going to be my answer. And I think we get 54.59 rounded. So, hey, that wasn't too bad at all, actually. All right, just a reminder, if you have additional questions, some students have been messaging me on Remind for Precalculus. It's at Munyon3 is the code, easiest way to reach me. Worst case scenario, you can email me, but if you don't have internet, you can still use text message to the number at 81010 to get signed up, and you'd be able to message me on Remind. Please, I also want to remind, if you're paying attention to the end of this video, that your semester grade is coming from Edgenuity. So regardless of the 4th and 5th, 6th weeks, they literally counted for nothing because your grade is a pass-fail, and it's based on what you've done on Edgenuity. So please make sure that you're at least attempting the material, spending some time, getting close to passing, if not passing all of your quizzes. You only get 3 tries on them. Let me know if I can help you.